Hello everyone, I'm Tushar Rahul. Welcome to today's explainer. In this video, I'll walk you through the core process of a simple RAG retrieval augmented generation pipeline. The same approach I used in a chatbot that I, along with my friend Shushmita, built for our college website. If you'd like to check out the project, I've shared the link on my LinkedIn. Just look in the description or bio. By the end of this video, you'll not only understand how RAG works, but also why it plays such an important role in modern AI applications. So, let's dive in. Imagine we have our data stored in a PDF. Think of the PDF like a digital book. It can have many pages filled with information. Now, let's take just one page from this PDF. The next step in the RAG pipeline is called chunking. So, what is chunking? Chunking is basically a strategy to make information easier to process and remember. Instead of handling one huge block of text, we break it down into smaller, manageable groups, which we call chunks. Let's see how this looks in action. Suppose the page of our PDF is divided into 3 smaller chunks. That's chunking in practice. Once chunking is done, these chunks are then passed into an embedding model. Now comes the role of the embedding model. An embedding model is used to convert both the knowledge-based documents and user queries into numerical representations, also called vectors within a shared vector space. In simple terms, it converts text chunks into vectors. These vectors are high-dimensional numerical representations that capture the semantic meaning and context of the text. The interesting part is, pieces of text with similar meanings will have vectors that are numerically close to each other in this high-dimensional space. All of these generated vectors are then stored in a vector database. A vector database is a specialized database designed specifically for storing, indexing, and quickly searching high-dimensional vectors. Now, let's see the simple revision of the process we came across. We start with data in a PDF, break it into smaller chunks, and then use an embedding model to convert those chunks into numerical vectors that capture their meaning. These vectors are finally stored in a vector database, which makes it easy to search and compare them based on similarity. Now that our data is trained and stored as vectors in the vector database, we no longer need to go back to the original PDF. The next step is to connect the embedding model and vector database with an LLM and a user interface. This is where everything comes together, and before we see how it works, let's first understand some important terms. LLM, large language model. An LLM is an AI system trained on vast amounts of text data. Because of this training, it can perform many language-related tasks like writing, answering questions, or translating in a way that feels very close to human understanding. For our case, we'll be using a pre-trained LLM. What is a pre-trained LLM? A pre-trained LLM is an AI model that has already been trained extensively on massive amounts of data for general language tasks. In simple terms, think of it as a ready-made, smart foundation that we can build upon for our specific project. Instead of training it from scratch, we can simply download the model or even use it directly via an API in our projects. Now, let's talk about the user interface, UI. A user interface is simply everything you can see, touch, or click when you use a device or application. It's the meeting point between you and the technology. The UI's main job is to take your instructions like typing a question or clicking a button and then give you information back in a clear way. In simple words, the UI is the look, layout, and feel of an application's front side, the part that you, as a user, directly interact with. Okay, now that you understood the core concepts and process, let's dive into how we actually create the chatbot. Imagine a user who wants to interact with our chatbot. The user types a message into the chatbot through the UI, and the chatbot then sends back a response. Here's how it works. As soon as the user sends a query, the chatbot takes that query and triggers an internal process that works behind the scenes to generate a meaningful response. Let's take a closer look at what this process looks like step by step. This is the overall flow of the chatbot we designed for our college website, and that's how it works at a high level. Now, let's take a deeper look into each step so we can better understand the process of how it all comes together. When a user types a question into the chatbot through the user interface, the chatbot first takes that query and passes it to the embedding model, which converts the text into a numerical representation called a vector. This vector captures the meaning of the query. Next, the chatbot sends this query vector to the vector database, where it is compared with all the stored vectors from our knowledge base. The database then finds and returns the most relevant chunks of information that are semantically close to the user's query. These retrieved chunks, along with the original query, are then sent to the large language model (LLM). The LLM uses both the user's question and the retrieved context to generate a clear, accurate, and context-aware response. Finally, this response is displayed back to the user through the UI, completing the cycle of interaction. And that's it. You now know how our college chatbot works using RAG. If you found this explainer helpful, don't forget to like, share, and subscribe. Also, if there's any topic you'd like me to break down next, drop it in the comments. Thanks for watching, and see you in the next one.